This video, I'm going to go over the material from lesson 5.6, and I'm going to focus on the objective for for getting the characteristics of rational functions. And then you'll see in Delta Math, when you type in all the different characteristics, it will graph it for you. All right, so there's this little table here I put, just a reminder from when you did this last year in Algebra 2, that you're going to use this table to help you figure out your horizontal asymptote depending upon the degrees, so the highest exponents in the numerator and in the denominator. Okay, so here's the first one we're going to do. The first thing I always look at when I do these for rational functions is I first see if I can factor anything. Now this one actually is completely factored to starts. We're good there. Then once you factor, I look to see if I have any common factors in the numerator and the denominator. That would mean I can cross something out and would create a hole in my actual graph. You can see on both of these, in the top and the bottom, I do not have a common factor, so I'm not going to have a hole. So I just put a little comment here, like I'm not going to have a hole, so no hole. Now, you can go in any order that you want, right? We're going to write down all this stuff here, x-intercept, if there's more than one, y-intercept, the asymptotes, and then any holes. So we can already put none for holes. All right, so I'll start with the intercepts. To find the x-intercepts, I'm going to set the numerators equal to 0. So x plus 2 equal to 0, and x minus 3 equal to 0. If I move over the plus 2 with a subtraction, I get x equals negative 2. If I move x minus 3, that minus 3 over with addition, I get positive 3. So my two x-intercepts, and you can write x equals those values, but I'm going to write negative 2, comma 0, and 3, comma 0, because those are my ordered pairs that would be for my x-intercepts. To find the y-intercept, we're just going to plug in 0 for wherever you see x. So I'm going to do 0 plus 2 times 0 minus 3 all over 0 plus 1 squared times 0 minus 2. All right, so now I'm going to kind of evaluate this. 0 plus 2 is 2. 0 minus 3 is negative 3. 0 plus 1 is 1 squared is 1. That's going to be negative 2, so this becomes negative 6 over, that's going to be negative 2, which is a positive 3. So my y-intercept is going to be 0, comma 3. Okay, now to find the vertical asymptotes. The vertical asymptotes are where you're going to, let me actually go to the next slide for the asymptotes. Your vertical asymptotes are where you're going to set your denominators equal to 0. So we have two factors in the denominator, x plus 1, all of that squared. Set that equal to 0. And the other one is x minus 2. Now the one on the right is pretty straightforward. I'm going to move over the minus 2 with addition to get x equals 2. This one is a little bit tougher. To get rid of that square, I'm going to take the square root of both sides. The square root of 0 just stays 0. So this is x plus 1 equals 0, or x equals negative 1. So my two vertical asymptotes are x equals negative 1 and then x equals positive 2. All right, now for the last one, the horizontal asymptote. This is all about looking at your degrees. So the degree of the numerator and then the degree of the denominator. Okay, so if I look at my numerator, I have x times x, right? X times x, which would give me x squared. So my degree is 2. My denominator would be, this one is already squared, then times x would give me cubed, right? So you can think of, right, this is like a squared, x squared, and this is x cubed. So again, I'm using this table up here, right? You can use that if you forgot it from last year. Because the degree of the numerator is less than the degree of the denominator, our horizontal asymptote is y equals 0. So y equals 0. All right, so that's the process for how to find all of this, all these characteristics. And I'm going to transition now to showing you how it looks on a few Delta Math practice questions. So flip in your packet if you haven't already. Find this page. All right, we're going to try these two. All right, and then I'll give you a chance to go to your Chromebook and try them on your own. So again, whatever order you want, asymptotes, intercepts, if there's any holes, whatever you want. I usually do the holes first because you can see that when you factor. So let's go ahead and factor here. Factor out the -5, which leaves me with x minus 2. All right, and if I factor this quadratic trinomial in the denominator, I have x and x. What are factors of 2 that add to -3? That's going to be -2 and -1. And when I do that, you'll notice, right, you should notice that we have a common factor, right? So these are going to cross out. Now what that does is it creates a hole, all right, at x minus 2 equals 0, or your hole is at x equals 2. All right, so when we, here in a moment, we're going to figure out what the y value is for that hole, but always set your factor that you cross out. So set your common factor equal to 0 to find that x value. So here's the function I'm going to keep going with. It's going to be -5 over x minus 1. All right, so if to find the y value for the hole, I'm going to plug in that x of 2, where it says x, get -5 over 1, which is going to be -5. So my ordered pair for my hole is going to be 2, comma, -5. All right. Now let's do the x-intercept next. Right. The x-intercept, there's actually not going to be any. If you remember from the previous example we just did, the x-intercepts, because now again, let me remind you, I only care about this going forward. Right. The x-intercepts are where you set the numerator equal to 0, but only thing in the numerator is a -5. And if there's a constant in the numerator, we can never actually get that to be 0, so that's why I put none for x-intercepts. Now the y-intercept, we can figure out. I'm going to plug in 0 where it says x. So I'm going to do -5 over 0 minus 1, so it's -5 over -1, which is 5. So my y-intercept is 0, positive 5. And then for the horizontal and vertical asymptotes, I think vertical are a little bit more straightforward. You set the denominator equal to 0. That's x equals 1 for the vertical asymptote. And then for the horizontal asymptote, now that we're looking at this is really like -5 times x to the 0 power. And this is, right, x to the first power. So if I look at the degree of my numerator compared to the degree of my denominator, right, the degree of my numerator is less than the degree of my denominator. So my horizontal asymptote is the same as the last one, which is y equals 0. So these are all the characteristics in number 1. And again, I don't care about the order that you do. I will say most students will find the hole first if there is one, because that happens as you factor. Okay, let's try one more, number 2. Can't do anything about the bottom, but I can factor out that -2 on top to get x squared plus 6x plus 9 all over x plus 3. If you factor out that numerator, that quadratic trinomial is actually going to be the same factor written twice, right? Because 3 times 3 is 9, plus 3 plus 3 is 6. So what I want to make sure we see on this example is that when you cross out, please only cross out one of the factors on top. Okay? You're not going to cross out both. So I am going to have a hole at x plus 3 equals 0, so where x is -3. I'm going to write down what I have left, which is -2 times x plus 3. So this is what I care about in terms of answering the rest of my questions. All right, so let's find the y value for the hole. So I'm going to plug in where it says x. I'm going to plug in -3. That gives me -2 times 0, which is 0. So my hole is going to be -3, comma 0. Now, I'm hoping that you saw it. If you haven't, that's okay. Right, we're just starting this. Right, that actually with a y value of 0 is what we call an x-intercept. So again, right, to find the x-intercept, I would set this numerator equal to 0, right, and I would find this -3. But guys, if we have a hole at -3, comma 0, then I can't actually have an x-intercept there. So I'm going to put none, right, and I'm going to put in parentheses because of the hole. Okay, let's do the y-intercept and plug in 0 for x. That's going to be negative 2 times 3, which is negative 6. So my y-intercept is 0, negative 6. All right, for my horizontal and vertical asymptotes, what you might have noticed is that we don't actually have a denominator anymore, right? So I don't have any vertical asymptotes if I don't have anything in the denominator. So that's none there. And then in terms of the horizontal asymptote, I don't have a degree in the denominator, right? So I'm not going to have a horizontal asymptote because, again, I don't have a denominator anymore. So I can't compare the degrees if I don't even have a denominator anymore. Okay, so this is going to be what I would type in for number 2. So make sure you take out your Chromebook, have these notes with you, make sure you're asking someone around you for help, and do your best, and we can talk about it when I get back. Good luck.